Hello, good evening. Welcome to today's session for our AI Everyday Virtual Bootcamp Season 2. This is Data Science Nigeria. Data Science Nigeria is a registered non-profit organization with a vision to build a world-class artificial intelligence, knowledge, research, and innovation ecosystem that delivers high-impact and transformational research, business use applications, AI for startups, employability, and social good use cases, such that in 10 years, Nigeria will become one of the top 10 AI talents, knowledge, destination with 20% GDP multiplier impact. 1 million AI talent in 10 years. That's our slogan. And these are some of our most important numbers. Our Artificial Intelligence for Startup book with professionals from all over the world sharing their thoughts about AI has more than 1 million downloads from our website. You can check it out too. We've had more than 10,000 people participate in our machine learning competitions. We have an AI knowledge box with more than 2,000 videos, materials to get better at AI in our knowledge box. Direct internship placements and jobs, research students. These are some of the most interesting things about Data Science Nigeria. This is what our schedule looks like when we're in session. And our Artificial Intelligence Bootcamp, we're still looking forward to the version for this year. It's one of our biggest and most interesting and one of the most interesting platforms where people from all over the world, some of the brightest mind in AI, they gather, they get better, they teach, they learn, and we're looking forward to that. And this is a link to view our annual report for 2018-2019 to read some of the most impactful things that we did during the year. And these are some of the organizations that we've had trainings with that you can testify to some of the amazing things that Data Science Nigeria that we do well. And our analytics training for professionals, it's usually weekends, a series of weekends where it's one-on-one hands-on training where we take you through the process. It's not mere payments when you decide to enroll for our paid courses, or even when it's not paid, we give our best. And these are some of the things that we can train for. We can train HR for data science for HR, data science for banking, data science for fintech. And today, some of the attendees of our past paid trainings, they will share some of the experiences so that you can be part of this. Thank you as you listen.
Okay, so I chose data science because, it's the future.
The vision of DSN, I identify with it. It's something I can relate with, the vision of wanting to create a hub for data scientists in West Africa. It's something that is highly needed.
Yeah, so far so good. It has been a wonderful one. I was able to learn the use of data to interpret data, to predict the future, definitely.
My big take home is probably sentiment analysis and then the use of big ML.
Today we did data visualization, dealt extensively with Power BI. There's a whole lot I can do with it. Things that we've been trying to analyze, I can now visualize it and it will make more sense to my audience.
Big ML majorly, it has been my own major takeaway, and the lectures were so broken down such that anybody can understand it.
What Sheon told me is lesser than what I even experienced there. The facilitators, they took us like children. It was like a dummy taking the course.
Tell everybody I come in contact with, especially young people in school right now, jobs as we know it will no longer exist. So you should get trained, in one of the technical skills. It could be data science, machine learning, artificial intelligence. That is the future.
So for me, DSN, the vision, is something that every forward-looking Nigerian should identify with.
Hello, good evening. Thank you for joining to this class. This is part of our series, Virtual Bootcamp at Data Science Nigeria. And today we'll be walking through natural language processing with TensorFlow. The pattern of this course is that I will explain some of the fundamentals of natural language processing, and we will use some of the methods that are available with TensorFlow in this course. Okay. So for this course, the most important question that I want to say is many people avoid natural language processing in the AI community. I don't know why. It's interesting, and this is my reason why natural language processing. Okay, there should be a comma here. Why natural language processing? Okay, a question mark. Why natural language processing? It's everywhere. It's our speech, is what we write, and you cannot avoid it. You cannot avoid working with text data. You cannot avoid working with unstructured data, like many people call it. So, welcome again to this class. We are in this together. Okay, so this is the definition of natural language processing. We'll just read this together. It's a collective term referring to automatic computational processes of human languages. So NLP is not just English. If you are used to saying maybe reading papers just in English, it applies to any language that is written, that is spoken. You can use NLP methods on them. And this includes both algorithms that take human-produced text as inputs and algorithms that produce natural-looking text as outputs. This particular definition talks more about text. It's not just text. There's speech too. That's a major part of natural language processing. But it looked comprehensive, and this is the one by Wiki, which I think is more comprehensive. It's a subfield of linguistics, computer science, information engineering, artificial intelligence, concerned with interaction between computers and human languages. In particular, how to program computers to process and analyze large amount of natural language data. Processing a large amount of natural language data is one of the ways in which AI excels. Deep learning excels at that. It doesn't really care about the size. The moment you put a method, you use the right algorithm, you're just fine. And it's challenging. It's challenging for computers to process text data. For many of your virtual assistants on your phone, your Siri and Google Assistant and all that, they are learning, but many of them, if you still do not speak like phoneme, it's not like they understand your Nigerian accent. It just shows one of the ways that it's difficult to train the systems to act like humans, to listen like humans, to do that. Okay, and I have a long list of common NLP tasks. You tokenize, you break words, sentences into subunits, you do sentence boundary detection, you do shallow parsing. Some of those NLP tasks, they are not new. They are things that linguists, they've done, it's a whole mixed field of computational thing. And if you work with NLP, you'll find some really old data sets. It means that people have been curious about how to make computer understand natural language, and this is another long list. I like named entity recognition. I do a lot of that. Information extraction, terminology extraction, topic modeling, summarizing, all manner of word similarity. All these are NLP tasks. Natural language generation, that thing where you're trying to generate new text. I did one with TensorFlow recently. It was quite cool. Speech recognition, your assistant speech synthesis, question answering, search engine, NLP is in how you search on Google, the autocomplete thing that it does, the auto prediction that your phone does, how your phone learns those things. Those are all cool NLP stuff. Sentiment analysis, text coherence, fake news detection. There are just so many things that people are doing with NLP that at least there should be one or two that you're willing to learn and get great at. And like I said, a major part of this course is to teach the fundamental of most of these things, what goes on behind them. Like there are certain tasks that you will do, whatever you're doing, you tokenize, you do all that. I'm sweating. Okay, so I found those interesting demo, and I found this interesting demo, and I thought that we can walk through it together. It's by Allen NLP. They have this really cool stuff, and they what they did. Let me go to the page. You can click here too. You can click here and join. I think I should just put it in the comments too, so that you can just join this. Is that we will be looking through several instances of several use cases of NLP of NLP. I hope the internet is working well. Okay, so so what they did here is that they put different text samples, and then you can just choose the title, and then they did this really cool thing where you can pick a model. It could be a neural network, it could be a machine learning model that can solve this, and then we see the response. So here you can just do named entity recognition, and they put the papers that they are following. So you can choose a sample text here. This is something about okay, let's go for this Grandpa Joe's own. Okay, so here we have an option of Elmo NER, fine grained NER. There are many other types of NER models, many. So let's run that. Let's see what it brings out. Okay, so this system was able to figure out that Grandpa Joe's is an organization, which I think is it's smart, because it could figure out that this is an organization. It didn't say Grandpa Joe is a person. Let's see what this other NER model will do. Let's see if it gives the same thing. Okay, it does the same thing. Let me see. I hope the internet. Okay, I think this is really cool. I think it's really cool what Allen NLP did here. You should come try it out. And this is a sentiment analysis. Let's just pick one. Let's see. We're trying to know if the model will figure out the sentiment of this. So let's see what it finds out. Okay, the model could figure out that it's negative. So probably constitutes cruelty. Okay, there's cruelty there. Mostly that's all. Let's see what Roberta will predict. Okay, it was still able to figure it out that it's negative. Let's find something else to do. All these are, clickable things. I encourage people to click a lot. If you'll be good at this, if you're new to programming, new to NLP, you should just click a lot, see what's going on with things. I saw one cool one about let me see this language modeling. You will find something cool there. Okay. Okay, I think this is cool for you to be able to figure out what it means. This is supposed to be like a proverb or something. And this is the premise. So let's see what these models will say about it. Let's run this. It is very likely that the premise entails the hypothesis. Probability. Okay. And I wanted to try question answering. Okay, so please play around with this. I think this is a really smart way of learning all these NLP things that you've been learning. These are different tasks which they've tried to put models that people have worked on, and then you can just play around with it. And okay, so let's go back to our presentation. Okay, so even though NLP is mostly speech and text, our focus is going to be on mostly text. Yes, that's what I prepared for, mostly text. And this is a general preprocessing framework for text processing. That means that no matter the tool you're using, there are several libraries for NLP, there are several frameworks, and under the hood, sometimes some people don't know what goes on beneath, but these are some of the most important tasks that goes on when you're doing NLP and, basic text pre-processing. And my perception about this is that the better you get at pre-processing text data, the better the better your outcome in NLP, the more confident you are to try new things, to try new libraries, because things are evolving really fast, and you just know that, if you're trying this method, somewhere in between they've tried to remove noise, they've tried to normalize, and they've tried to tokenize. Whether you're working with maybe an eye level that you don't know, an eye level API that you don't know what is going on beneath. These are some of the activities that goes on beneath. And okay, I think I can just use this. Okay, so tokenization, this is a very popular task. It's something you always do. So it's either you're breaking a sentence into words, or you're breaking a paragraph into sentences. You're just bringing it to the basic data set. We'll discuss further about how powerful tokenization is and why it's really important. And normalization is just like what it means with figures, like you're trying to bring words to a level playing field. So for text data, rather than let some word start with uppercase and lowercase, you can just lowercase everything. There's a way it improves computation, because then many more words come to, you can just attach, whether you that started with a capital Y or you that started with a small y, you can just assign the same index to them. And and then there's lemmatization. Well, lemmatization is quite systematic. It's there's a lot of grammatic things that goes on behind it, but this is an instance of lemmatization. Live, living, lived. Their root word is live. So it just brings everything in that word to live. It's mostly a way to reduce the volume of text that you are processing. Systems like doing things like word embedding now, and with the advent of deep learning, you don't need to stem, you don't need to lemmatize. And stemming is the poor man's lemmatization. That means it just chops it off. Like if it is living, it can just remain like liv for you, or if it's lived, it can just remain live. That. So but the most popular, the most cogent difference between stemming and lemmatization is that lemmas must always have a meaning, but stemming, after the word has been preprocessed, it may or may not have a meaning. And then noise removal. This is something that, as simple as it is, it can really make your life difficult when you are processing text. Let's say you've extracted tweets. If you don't remove maybe the URL, the HTML tags, it's something you get to regret often. So those are some of the most important things that goes on behind almost every NLP, natural language processing kind of work that you'll be doing. Okay, and here are some pre-processing text. For the reason these are just some pre-processing text is that sometimes you don't get to do all this. But you always do some. If you're not tokenizing, you're trying to remove special characters, you're maybe trying to remove all lower cases, but these are just instances. Sometimes you don't want to remove your numbers, like let's say text as COVID-19. I like the 19 there, like it's part of the word, so you probably won't remove number in that kind of context. Yes, and there's the thing of stop words about what that people consider not important. Although my personal philosophy is that if you can compute it, I think you should keep your stop words, because sometimes they have great effects on how you're about capturing the contexts of the words that you're doing. So many times I keep stop words. I do keep stop words. I don't remove stop words, but maybe you're trying to reduce the level of computation, like how expensive it is. You can remove stop words, but I don't like it. And this expand contraction, it's really interesting. It's something that I learned from reading Dipanjasaka's tutorials. Yeah, I'm a fan of Dipanja. So it has this code snippet that I always borrow to expand the contraction. That means if it says don't, it changes it to do not and things like that. I think it's really smart. In preprocessing your text is like a form of normalization. So that some things are not in apostrophe and some other things are in other form. And removal of extra white spaces. If you've been coding, white spaces are evil, especially in Python. Strip them off. Okay, so now we're going to do NLP with TensorFlow. TensorFlow is a framework by Google. If you've done deep learning, if you've done deep learning, you probably tried out TensorFlow. And I remember the very first time I tried TensorFlow 1, it was quite difficult. That was then. I wasn't a confident coder then. but now I think the TensorFlow 2 API, especially with Keras integration, is brilliant, and you enjoy working with it. For most of the deep learning, most of the natural language processing that you'll be doing with TensorFlow, they are okay. I'm trying to load this. I hope the internet is on. I want it to be live. Okay, so I hope, so for TensorFlow, so let me reconnect this so that we can run the notebook together. Many times if you're doing a computation that has to do with GPU, okay, so for TensorFlow, where you will where you will enjoy TensorFlow is for when you want to use deep learning algorithms. So, it's optimized for training of large data set, processing of large data set. And like I said, I think the new APIs are interesting and quite well explained. So let's go to our notebook that we'll be running together. Many times, if this is your first time using Collaboratory Notebook, it's by Google. It's a Jupyter notebook, and it works online. And I like it a lot. Okay, so there's no hardware accelerator. We are not running every computation, but if we were, there's GPU support, which is brilliant and generous. So you can just do that and you have this. So let's go to the beginning of the notebook. So most of what we'll be doing with TensorFlow is how to preprocess with TensorFlow, and many of the codes in this notebook, they are from the official documentation. So to start this, I didn't know about capture for a while, but capture is when you don't want, when you're maybe pip installing, you don't want to see the output in the notebook. So let's try it. Let's play. So without capture, if you are pip installing, it gives you this. Okay, so if you're installing, it gives this long thing. Let me stop that. Okay, so I'm interrupting the keyboard so that I can just put the capture. I like tidy notebooks, so you can just put this, and then we have this. So there's the TensorFlow.text API by Google. It's mostly for text preprocessing when you're working with TensorFlow. But it's not my first choice. It's not my first choice if I'm preprocessing text. There's the tf.keras API that I use. It's the first choice. But that's what this API is about. So we should talk about it. We are discussing TensorFlow. So we pip install TensorFlow text, and then we can continue. Okay, I ran this before. So let me just go to... Okay, we are using TensorFlow 2. All notebooks and collaboration notebooks have moved to TensorFlow 2, and then we'll talk about text encoding. When you are preprocessing text, it's important, or any form of text, it's important that you pay attention to the encoding. The most popular encoding that works across many languages is UTF-8. Sometimes you get text that are maybe Latin 1, UTF-16, ASC, ASCII, and you have this this character encodings that are not that suitable, but most times please just use UTF-8. And sometimes when debugging your code, I remember I was running a particular code and I was getting terrible errors, and everything changed when I just decided to encode everything to UTF-8. So sometimes to be safe, you just encode everything. So there's a sample text. This is from the Google official for text encoding. So the only thing I did a bit differently was to view what the docs look like. I'll say whether you're a beginner or you're trying to get better, do this often to just see the state of things, to just see what your code is saying. If you're learning from a notebook, you should type it out, attempt things, change things. So, okay, I put this introduction to text preprocessing myself, and it's encoded with UTF-16, and this is what it looks like. I don't understand this, but when it was encoded at UTF-8, it's back to normal. So I just did this to show the difference between encoding, and there are many types of encoding that you should know about. But UTF-8 is your favorite and the most useful. Okay, and now we have tokenization with TensorFlow text. In natural language processing, the popular libraries, NLTK, Spacey, Jensen, everywhere that you are processing text, you always have great tokenizers. So this is a white space tokenizer, which I think is the most intuitive. There's a sentence, split them by white spaces. And the real purpose, one thing that should always be at the back of your mind when you're working with text data is that the computers do not read text data. It has to be in a numeric form at one point or the other, and that's for me, that's the holy grail of preprocessing text. It will be in insane numeric format. So, and tokenization is usually the first stage where all the sentences are broken down into their tokens. And there are tokenizers that pay attention to punctuations, that see punctuations as characters on their own. Example is this Unicode script tokenizer. I think in NLTK is punked tokenizer. And when you're working across libraries, it's why I'm a bit obsessed with understanding the concept. The implementation may be different, but tokenization is tokenization, and you can always pay attention to things like this. Do you want the punctuations there? Do you want it without punctuation? And that's how you search for things like this. So this is a white space tokenizer, which is intuitive. It just splits the words by the white space. And this is a Unicode Split that works well with people that work with maybe Chinese, words that are characters, not words. And then it can split into individual characters, which is exactly what it did here. And then offset. For me, offset is this. It's not even for me. Offset is the same thing like span. If you work with spacing, it's just how spacey. If you're maybe doing anyhow, it shows you the span. This word that is here. This is the beginning. This is the end. You can do that with TensorFlow, and you have it here. And of course, TensorFlow text and all the preprocessing method with TensorFlow is optimized to work well with TensorFlow, obviously. And now, okay, it works with tf.data too. And then for your basic NLP tasks, do you want to know if it has a title case? Do you want to know if the tokens are uppercase? If it has this, and that's exactly what happened here. It's the word shape. So the module here says word shape. And if you work with Engrams, if you work with TF-IDF, time frequency inverse, you will have worked with Engrams. So these are bigrams because it's 2, you can do 3. And this was how text predictive models used to be trained before embeddings took over. Words are learned in Engrams to know, the word that has the highest probability to come after one or the other. And, some people say the optimal Engrams is 3, some people say 4. But the more the Engrams, the more the computational space is. And yes, so now we're going to tf.keras.preprocessing for text data. And this is what it looks like. When you're learning a new library, when you're exploring things like this, do not be afraid of documentation, because they tell you exactly what this is doing. So now I know that for For this tokenizer, there is the number of words, which you can leave none. There are filters. These filters are simply punctuations that you want to remove. Lower is putting all the text characters in lowercase. Do you want to split by white space? That means depending on what you know about your text, that means you can manipulate this. These are hyperparameters. These are things that you can manipulate out of vocabulary words. Out of vocabulary is very important when creating sequences. Creating sequences to be fed into deep learning neural networks, because that way, because you know that most times whatever you're training will not cover out of vocabulary words. There should be a form of representation so that your model is not confused that it has not seen those words before. So we are going to experiment with the tokenizer of the TensorFlow Keras Preprocessing class. So let's import, except I want to write it, and then you can call this. You can instantiate this. This is a sample train text. This is a sample test text. When you are working with this, the moment your fitting should be on train data, not on test data, and that's the purpose of this token, this out of vocabulary token. We are aware that I'm aware, and we are aware that sometimes the words here are not here. Like now, this model is fit, this tokenizer is fit on COVID-19 is a pandemic, wash your hands, but here is saying COVID-19 is a viral infection. So to make account for this viral infection, because of course it's going to indexes and tokens, to make that's what this OOV token is like. And again, documentations are your friend. This is written on the official website. It's on Stack Overflow. It's in everywhere that you ask questions. So this tokenizer, we called just the default. Nothing was changed. I didn't make account for out of vocabulary index, and then it was fitted on the train set. So for word index, how word indexes work is that the word is attached to a particular word, no matter the number of times that word appears in the document. So every time there's mask, there's number 12. Every time there's face is 11, and that it's a dictionary. So, and let me see. And then we convert it to sequences as we prepare to feed it into a neural network. So for each of the sentences, COVID-19 is a pandemic. We know that COVID is 1. 19 is 2, is 3, a 4, pandemic 5. It's just arrange the sequences like that, and now each sentence has been put into a sequence, and then we can okay, I did the viewing, and then I assigned it to a variable, a sample train sequence variable, and I just printed again because I always print again. You can convert the text to a matrix. That's exactly what you did here. You don't need that, but if you want to, this looks like a one-line encoding. And then for your sequence, you can pad the sequences. Padding sequences is like Lauren said in this class on Coursera, is similar to when you do CNNs with images and you just pad the sides so that they are not unequal. And what I would like you to pay attention to is that padding has the pre-class and then it has the post-class. I prefer post. It means that anywhere the sentences are not equal, like now the first sentence here, it has 5 tokens, but the last sentence has 3. Logically, just to put it in the same place, you just pad the last 2 spaces with zeros so that it's the same size, and it makes the life of your model too easier, and then you don't get these error messages. And then some people do pre. The default is pre. I like post, like so that I know that where I have the 0, 0, 0, 0, 0, 0 zeros, they are just the padded sequences. And now that we have a padded sequence, Now that we have a padded sequence, all sentences, they are the same size, and this can now be fed into an embedding layer, okay, for your neural network. I hope this has been an interesting class. My thoughts are that you guys will have a lot of questions and, get better at NLP. And you have a great day.